Vanakkam to everyone. I am Revati Chinnathambi from the Department of Physics at Aged Metric Higher Secondary School, Apputotam, Konganapuram. In this session, you will learn about an electrostatic potential energy. Initially, I will keep a point charge with the magnitude of plus q at origin O. Now, this point charge will produce E of magnetic field strength around it. To determine the electrostatic potential energy due to this point charge, I will bring a point charge I will say like a test charge the magnitude of plus q dash from the point R into point P. Now the direction of this test charge towards the plus q charge which is kept at a origin O. According to Coulomb's law, there is a electrostatic repulsive force between these two point charges plus q and a plus q dash. Therefore, the work done must be done to overcome this repulsion. I am bringing this point charge from R to P means there is a electrostatic repulsive force. I want to overcome this repulsive force means need to do external work. This work done only stored as electrostatic potential energy in this system. That work done only stored as the electrostatic potential energy in this system. Let's see. The test charge q dash is brought from R to P with constant velocity, which means that the external force used to bring the test charge q dash from R to P must be equal and opposite to the Coulomb force. Why? Because in this case there is a repulsive force between q and q dash. Already we saw that this repulsive force only electrostatic Coulomb force. That is what that external force F external is equal to minus of F Coulomb force. Then the work done W is equal to integral R to P F external dot dr vector. This is equation number 1. Since Coulomb force is conservative, so that the work done is independent of the path. What is meant by that? The work done independent of the path means this plus q dash charge reached into point P. In other words, this plus q dash test charge brought from point R into P in any path. The work done is depends only on the initial and final position of the test charge. If the potential energy associated with the q dash at P is UP and that at a R is UR, that means the electrostatic potential energy at point P is considered like UP and point R is considered like UR. Then the difference in potential energy is defined as, note down this, the work done to bring a test charge q dash from the point R to P, that is UP minus UR is equal to W. In other words, this UP minus UR only difference between the two electrostatic potential energy at these 2 points. That means the difference of electrostatic potential energy is represented like del U, that is equal to work done W. This is equation number 2. Now I am going to apply this equation 1 and 2 in equating condition. Therefore, del U is equal to integral R to P F external dot dr vector. This is equation number 3. According to the basic definition of electric field E, that is equal to F divided by Q, from that F is equal to E into Q. This is equation number 4. Therefore, F external is equal to minus F coulomb force, that is equal to minus Q dash into E. This is equation number 5. Substitute equation 5 into equation 3, we get del U is equal to integral R to P of minus Q dash into E vector into dr vector. That means we will take this q dash outside. Therefore, del U is equal to integral R to P q dash into minus E vector into dr vector. Then finally, we will get this q dash again outside of the integral form. Then del U is equal to q dash of integral R to P into E minus E vector dot dr vector. This is equation number 6. Then the potential energy difference per unit charge is, I am going to divide this expression by q dash. Then we will get del U by q dash is equal to this whole term divided by q dash. Then right side of this applied form, q dash and q dash cancelled. Remainings are del U divided by q dash is equal to integral R to P into minus E vector dot dr vector. In other words, we can write this common negative taken outside. Then del U by q dash is equal to minus of integral R to P E vector dot dr vector. This is equation number 7. Note one thing here. In this equation 7, del U divided by q dash is independent of q dash. Here the quantity del U divided by q dash is equal to minus integral R to P E vector dot dr is called an electric potential difference between the points R and P. It is denoted as Vp minus Vr is equal to del V. This is equation number 8. Then define electric potential difference. Note down this. The electric potential difference is defined as the work done by an external force to bring unit positive charge from the point R to point P, that is Vp minus Vr is equal to del V, that is nothing but del V is equal to integral R to P minus E vector into dr vector. This is equation number 9. Then the electric potential energy difference del U is equal to Q dash into del V. This is equation number 10. Physically, the potential difference between the 2 points is a meaningful quantity, but the value of the potential itself at a point is not meaningful. 2-point charges means, we will consider 2-point charge means there is a potential difference between these 2 points, and we will consider only 1 point means that point at a potential only. That is why the value of the potential itself at 1 point is not meaningful. Therefore, the point R is taken at infinity and its potential is considered as 0. Therefore, V infinity is equal to 0. Then the electric potential at a point P is equal to, underline this, the work done by an external force to bring a unit positive charge with a constant velocity from infinity to that point P in the region of the external field E vector. Mathematically, this is written as Vp is equal to minus of integral infinity to P E vector dot dr vector. This is equation number 11. From the above equation, we infer that electric potential at point P depends only on the electric field, which is due to the source charge Q and not on the test charge Q dash. The charge which is kept at origin O, that is a source charge. Then which charge brought from the point R to infinity, R to that point P, that is Q dash, that only test charge.